In this segment, we'll finish our discussion of column modifications, looking at adding and deleting columns, and at changing indexes and constraints. As with prior segments, we'll start here with a fresh reload of courses1.sql, which you should also do. Now, to add columns to a table, you use alter table and then the table name, and add, and then a column description, like the one you might use in create table. So we'll try here adding a favorite color to person, thus, and try running this yourself, of course. And then after you do, as I will do here, do a select star on person, and we'll see, and scrolling that over a bit, we can see that all of the values in the new column are set to null. And those values raise an interesting question. If you add a new column, clearly all the existing rows need an initial value for the new column. Null makes a good choice and is the usual initial value, but what if the new column is declared non-nullable? Now, we could look up the rules for initial values of added columns, but this is a good chance to practice column adding and deleting, so let's delete and re-add this favorite color column with different declarations and then see what happens. So to delete a column, you type alter table and the table name again, and in this case drop and the column name. And remember that, as is typical for SQL, it is drop, not delete. And it probably goes without saying that this is another one of those take your hands off the keyboard and think actions before you do it. There is no Control-Z for column deletion. So question 1 here, drop and re-add the favorite color column and do it 3 times. I'll do first there, the first shot, and you can do that as well. Then re-add it as a non-nullable varchar, and then as a non-nullable int after having deleted it, and then finally as a non-nullable enum, making up whatever enum values you like. And after each re-addition of the column, confirm the new column via show create table person and do a select to find out what default values you get. So after what should have been a fairly lengthy little exercise there, what you should have come up with for the first case is that favorite color will be initially set to empty, nothing, an empty length string, in other words. And then deleting that, and then we can try adding it as a not null int and see what we get for our favorite color integer value, and we can see it's all zeros. And then once again deleting it and re-adding a third time as a enum, red, blue, and green choices, and we get the default first value in the enum, red. And of course, if you actually add a default value, declare the column with a default value, like perhaps alter table person add favorite color with a default of blue, and then the declared default would be used instead. Question 2. The add option offers the same extra syntax for column positioning as modify. Look that up if you need a reminder from the earlier lecture segment, and add a new middle name column positioned just after first name in the table. And you should come up with something like this. So alter table person add middle name varchar after first name, and we get that then. So let's move on here to discussing dropping and, as we'll see, adding indexed columns. In the prior segment, we discussed the interaction of modify actions and constraints like keys or indexes. Let's see how that works now with drop. Try dropping the columns person ID and for that matter also teaches.section ID and section.term ID in the three different tables there. What is the result in each case, and why does this result make sense? So I'll do just one of those examples by way of an answer, and that is to alter table section, and we'll drop the term ID from section. And that's not going to be happening. And it fails because term ID is used in a foreign key. And for the same reason, none of the three things I asked you to delete work, because each of them participates in a key or index on their table. Remember that any column involved in a primary, unique, or foreign key constraint is automatically also part of an index to enforce and to track that constraint. We'll refer to it as a constraint index from here on as a reminder. And the same principle applies to drop as to modify. You can't modify a column or drop it if that would disrupt a constraint or index. You must first drop the constraint that creates the index. So now let's look at how to add and drop constraints. First, by the way, before we get into that, into adding and dropping constraints, recall the convention for naming constraints that was introduced in an earlier module. Unique key and index constraints are UK, and then the column or columns that involve the constraint separated by underscore for column names in a multi-column constraint. Foreign key constraints are FK and child table underscore column list. And these include the table name, because FK constraints must be unique across the database. Again, all that's review from prior discussion. A primary key needs no name, since there can be only one per table. It's just referred to as primary key in alter table commands. Also, as we demonstrated, MySQL automatically generates unreadable names for constraints if you don't supply a name. So you should supply a name. Okay, with all that in mind then, table teaches has a number of constraints and corresponding indexes. So try running them by show create table teaches, and we can look at them. And there again are those conventional names I mentioned, like FK teaches underscore teacher ID. We can see the two foreign key constraints for teacher ID and for section ID that we declared in courses1.sql. And there's also a key constraint named FK teaches section ID right here on the third from last row. And we did not declare that one. So it sets up an index, apparently, that key, or a key on the section ID column, because it does refer to section ID here. An oddity, by the way, of the show create table output is that it uses key to show an index that we would declare with index in a create table statement. So you should see that as sort of a synonym for index there. Now, where did that key or index constraint come from? The primary key constraint, right above it, on teacher ID and section ID, is obvious enough. We specified a primary key on those columns when creating the table. But why did MySQL add another key constraint and corresponding index on section ID alone? One good way to find out would be to remove the added key and see what happens. We can remove any constraint with drop statements similar to those for columns, but we must specifically indicate that we're dropping a constraint by adding key or foreign key or primary key, etc. after the drop. It's not assumed from the name, since as you can see from this example, a column and a constraint may have the same name. So let's run alter table teaches drop key FK teaches section ID. And by the way, drop index will work here too. But we do find we cannot do the drop because the key index is needed in a foreign key constraint. Given the common name, FK teaches section ID, it's a reasonable guess might be that it's the foreign key constraint, FK teaches section ID, that needs the key. So question 4. Confirm that by dropping the foreign key on section ID. and figuring out the syntax needed to drop a foreign key from the discussion above and the docs is part of the deal. Then try dropping the fkteaches section ID key again and see if it works. So the commands you should have come up with here are first this one, alter table teaches drop foreign key fkteaches section ID. Okay, and then we're going to try to again drop the simple key fkteaches section ID, and they both work without error. So that confirms that the key supported the foreign key constraint of the same name. And in fact, looking at table section, we also see a extra constraint and corresponding index on term ID right near the bottom there to support its foreign key on term ID at the last row. It looks like every foreign key constraint also gets what we might call a supporting key constraint. And that's a term used only in these lectures, by the way, not field-wide, but a supporting key constraint. And it's listed separately from the foreign key constraint itself. Let's look more closely at the teaches table to see why we need a supporting key constraint. And to do that, of course, you're going to have to reload courses1.sql, which you should do as well, to restore teaches to its original state. We'll do a show create table teaches there. Okay. The foreign key constraint, each foreign key constraint, really requires its columns, for instance, section ID, to correspond to a primary key in another table, section. And that means that join queries may need to match a primary key from, say, section to the rows in teaches that link to it. The supporting key constraint that goes with the foreign key constraint speeds the lookup of values in that foreign key column. We could have the foreign key constraint without the supporting key constraint, but lookups from section to teaches would be slower. Question 5. Is the supporting key constraint a unique key? Could or should it be? The answer is no, it's not, and it shouldn't be. Foreign key constraints are many to one. It's perfectly possible for several rows of a table like teaches to refer to the same row of section. So the key that's involved cannot be a unique key. So just to follow through on this, why doesn't the foreign key constraint on teacher ID get a supporting key? And for a hint, consider the primary key of teaches. Could a join use that key to hunt for teacher ID key values? But then would the primary key serve as well for section ID values, given the primary secondary order of the columns in the key? Think about this, for example. If you were given a list of people ordered in last name, first name sequence, would it be easy to find someone with a particular last name? Would it be as easy to find someone with a particular first name? And the answer here is that an index with teacher ID as its primary key, as its first column, is as good as an index on that column alone, with no secondary column. If you search for keys with a given teacher ID value, they'll be all together in the index, like last names in that list of people. So if the foreign key on teacher ID needs to find rows for a given teacher ID value, the primary key's index will suffice. But searching for rows of a given section ID without knowing the teacher ID doesn't work well at all. This would be like searching for a first name in a list of people ordered primarily by last name and only secondarily by first name. People named John would be spread out all over the list. And likewise, keys with a given section ID will be spread out all over the primary key index under different teacher ID values. So, any foreign key gets its own supporting key constraint unless it's on a column that is also the primary column, or the first column, of an existing key constraint, in which case that existing key can be used. Okay, now let's drop and restore the foreign key on section ID with two improvements. Add the on-delete cascade and on-update cascade properties that were so convenient in the foreign keys in the table takes. So that's question 7. Look up the syntax and figure out how to add back that foreign key after dropping it with those two changes. So first let's drop it And then what we need to do is an alter table teaches, add constraint, fk teaches section ID, all that we had before, except that we're also going to add on delete cascade and on update cascade at the very end there. And running show create table teaches shows that we've restored the foreign key constraint with the desired on delete cascade and on update cascade properties. Okay, now let's try adding a constraint other than a foreign key constraint. Question 8. Add a constraint that forbids having two sections with the same department and course number and term ID. And the constraint should allow the columns to be nullable. First, figure out how you'd write such a constraint in the create table statement, and then figure out how to add one with an alter table syntax. So the answer here is that we need a unique key constraint, and you can add it with alter table section add unique, and with a list of the columns in question. That doesn't look like it's going to work. Well, checking the table content, we can see that we already have rows that are violating that constraint. Row 7 and row 8 are, in fact, direct duplicates of each other. So we can't add a unique constraint, apparently, if the table doesn't already comply with it. So we're going to delete the offending row. Is that going to be okay? There are people teaching and taking that class. Will we be allowed to delete it so easily? Why or why not? Can I just blow away row 8 here and it'll all be okay? And the answer is yeah, it's fine. Remember, I have on delete cascade conditions now in both teaches and takes. And that automatically removes all the rows in those tables that are relevant to this particular course. So removing that and then repeating the unique key command works. Now finally, let's try adding and removing primary keys, which might be needed if we, say, made a bad primary key choice and needed to revise it. So question 10. Given that the primary key for teaches, go back to that table, given that that primary key for teaches is not the target of foreign keys from any other tables, it does seem that we should be able to remove it. Is that so, based on our earlier conversation, though? Why or why not? And if you're not completely clear where the problem would be, it's within teaches itself. There's still a difficulty. And the problem, of course, is that the foreign key on teacher ID within teaches, remember, that uses the primary key as its supporting key constraint per earlier discussion. We'd need to drop the foreign key first, and then we could drop the primary key. Okay, so as an exercise, drop that dependent foreign key and then the primary key. There are primary key specific forms of alter table. You'll need to look those up. And then just for variety, first restore the foreign key and then add back the primary key, and do show create table after each step just to watch the evolution of key constraints. In particular, you'll notice a supporting key constraint will be created and then dropped automatically in the middle of all of this. So explain why that happens. Again, we're looking to drop the foreign key, then the primary key that it depends on, then restore the foreign key, and then the primary key. So what we need to do here is first an alter table teaches drop foreign key, and then a alter table teaches drop primary key, like that. And let's do a show create table teaches to look at what we've done here. Yeah, it looks like those are gone. Now we're going to restore the foreign key. Alter teacher table teaches add constraint, etc., etc. Okay, and then a show create table. See what that looks like. Oh, that's interesting. It's added keys for both the foreign key constraints. And that's because there's no primary key when we re-add the foreign key. So it's going to add an automatic supporting key. And then if we do finally add back the primary key, which we can do this way, again, special terminology, add primary key, and we do a show create table, we'll find that it dropped that extra key in favor of the primary key when we added it. So that's pretty clever.